Another algebraic method for solving systems of equations is called elimination method. This method is best used when both equations are in standard form, meaning x and y are on the same side of the equation and a constant is on the other side of the equation. If both equations are set up in the standard form, rather than solve for a variable x or y, we can use elimination method rather than substitution method. So in this first example, we have 2x plus y equals 9, and 3x take away y equals 16. So we're going to add these two equations together because I see if I add them, I've got a positive y and a negative y, and if I add those two things together, I'll get 0y, effectively eliminating my y. That's the goal with the elimination method. You want to get one of your variables, either x or y, to be eliminated, completely drop out so that you can solve for the other letter. So we're going to add straight down in all of our place value columns. So we're going to add 2x and 3x, and we'll get 5x. We're going to add positive y, 1y plus negative 1y. We're going to get 0y. Bring down our equal sign. 9 plus 16 gives us 25. Now 0y is really just 0, so the y's have effectively been eliminated, and we just essentially have 5y equals 25, because 0y is really just 0, because 0 times anything is 0, and 5x plus 0 gives us 5x. So we finish solving for x by dividing, and we see that x equals 5. We're not finished though, because remember, when solving a system of equations you have to find both the x and the y value. So you need to take that 5 and plug it into one of the original equations. I'm going to choose the top one. It doesn't matter which one you choose, no matter which equation you plug into, you should get the same answer when you're done. So 2 times our x value of 5 gives us 10, plus y equals 9. So we'll take away 10 to see that y equals negative 1. So our point of intersection, the only x, y that work in both equations, is 5, negative 1. And we can check that by plugging the 5 and the negative 1 into the bottom equation. So 3 times the x value of 5 minus the y value, which is negative 1, does that equal 16? Well, 3 times 5 is 15. Minus a minus turns into plus. And yes, 15 plus 1 does equal 16, so it checks. We already know the two values work in the other equation because we solved for it up here, but you could check that one as well. You could plug into your top equation and verify that it works there as well. Okay, here's our second example. So in this case, they are both in standard form. We've got x and y on one side, our constant on the other side for both of the equations. And what we can see is this time we've got x and an x. So adding straight down right now wouldn't help because I'd get 2x plus y equaled 7, so none of my variables would drop out, and I wouldn't be making any progress. But it would work if we subtracted, or if we just take one of the equations and multiply by negative 1. So I'm going to keep my top equation the same, but I'm going to multiply my bottom equation by negative 1. So that now adding will help. Now if I add straight down, my x's will be eliminated. They'll drop out, and I can solve for y. 2x plus negative x is 0x, so those are eliminated. Negative 2y plus negative 3y is negative 5y. Negative 9 plus negative 16 is negative 25. So we solve for y by dividing by negative 5, and we see that y equals positive 5. So now we're going to take that y value, plug it in to one of our original equations. I'm going to choose the second equation this time. Again, it does not matter. You should get the same x value. no matter which equation you plug into. So x plus 3 times our y value of 5 has to equal 16. Well, 3 times 5 is 15. I'll solve for x by subtracting 15 to see that x equals 1. So my point of intersection, the place where these two lines would meet if I graphed them, is 1, 5. That's the only xy coordinate pair that will satisfy both equations. So let's check that in the top equation. If we replace the x with 1, the y with 5, I'm checking to see if I get negative 9. Well, 1 minus 10, yep, that's negative 9. I can also check the bottom equation to be doubly sure. Again, replace x with 1, y with 5. 3 times 5 is 15. Does that give us 16? Yep. So it checks our xy value work in both equations, and you should always check your answer. You will always know if you found the correct solution to a system of equations. So you need to plug your x and y values back into both equations, make sure they work, and then you know you're right. If they don't work, you've got to go back and check your work somewhere you've made a mistake. Our next elimination video will take a look at what happens when our variables don't perfectly line up